Hello students. So today under the gravitation chapter we are going to find out the value of g. So what is this g? G is acceleration due to gravity. So in the free fall of the object we have known that this is the small g is called the acceleration due to gravity. Now so you know by this formula Newton's second law of motion and as well as from the universal law of gravitation we have derived the formula for the g, that is g is equals to g m divided by r square. Correct. By using this formula we are going to know what is the value of g. You know in a free fall of an object the value of g, that is acceleration due to gravity, remains constant, isn't it? So that is why we are going to derive this constant term here. So to derive that, you know what is the value of capital G, that is universal gravitation constant. Universal gravitation constant value is 6.7 into 10 power minus 11 Newton meter square per kg square. This is the capital letter G value. Similarly, you will have considered the mass of the earth. It is approximately we have considered as 6 into 10 to the power 24 kg. This is the mass of the earth we have considered, and also our radius of the earth we have considered 6.4 into 10 to the power 6 meter. Okay, by using all these terms, we can able to form or we can able to find what is the value of g. Let me substitute it. G is equals to capital letter G 6.7 into 10 to the power minus 11 into mass of the earth 6 into 10 to the power 24 divided by radius of the earth 6.4 into 10 to the power 6 whole square. So what we have solved the problem, same method you have to use it. 6.7 into 6 into, so 10 to the power minus 11 into 10 to the power 24, that means a power m into a power n means m plus n, that is minus 11 plus 24 means you will get it at 10 to the power 13. 24 minus 11 is 13 divided by 6.4 into 10 to the power 6 whole square. 6.4 into 6.4 if you multiply, I'll get it as 40.96 into 10 to the power 6 whole square. 10 to the power 6 whole square is nothing but 10 to the power 6 into 2, that is 12. So 10 to the power 12 I'll get it. Next 6.7 into 6 if I do, I'll get it as 40.2 into 10 to the power 13 divided by 40.96 into 10 to the power 12. Okay, so these values I'll write afterwards, that is 40.2 divided by 40.96 means here 1 point shifted, 10, 2 point shifted, 20, 10, 10 will get cancelled. So I'll get it as 4020 divided by 4096. Okay, if I divide this, you can divide it, this 4096 is greater than this one, so I have to put 0.98 into 10 to the power 13 divided by 10 to the power 12 is that becomes 10 to the power 13 minus 12, 13 minus 12 I'll get it as 10 to the power 1. That means 0.98 into 10, 0.98 10 to the power 1 means 0.98 into 10. That becomes, I'll get as 9.8. So acceleration due to gravity, g is equals to 9.8 meter per second square. Meter per second square, whatever acceleration will be having, the same thing we are denoting the SI unit for acceleration due to gravity itself. So what is the g value? This will be constant 9.8 meter per second square. Okay, you have to remember this. So in the questions, in the problems, you have to remember this value if they have not given. Many of the time they will give the constant value. If they have not given, you have to remember it. And also this value, that is g is equals to 9.8 meter per second square. Both these values you have to remember while solving the problems. So this is about to find the value of g. Okay. Then next we will go with. So next important one, motion of objects under the influence of gravitational force. So that means what the value of g will become, that is acceleration due to gravity, that will become when an object is in motion. To consider this, we are considering the equation of motion. You know what is the equation of motion? That is V is equals to U plus AT, first equation of motion. Next, S is equals to UT plus half AT square. And the third one is V square is equals to U square plus 2AS. Okay, or I can write V square minus U square equals to 2AS. Both the things are correct. Okay, here we are considering these three equations and I am making three objects. Okay, how I am considering means, first object I am considering, for example, an apple or any of the thing or falling from the tree. Okay, that means that a body dropped from a certain height. Okay, first thing is body dropped from certain height. From a height I'll consider. That is the first example I'll consider to check the equation of motion under that. Second object what I'll consider is body which is dropped, that is with some velocity. Okay, body which is dropped vertically, dropped downwards. Vertically downwards it is dropped. Okay, that is the second case I'll consider. Third condition I'll consider body which is thrown upwards. Okay, body or object which is thrown upward direction. That is the third condition I will consider. Now, under these three circumference or under these three conditions, what the equation of motion will become? What the g value, acceleration due to gravity, will become? So, let me make a table for this. First, I will consider equation of motion in one table. Equation of motion in one column. And next is first example. That is the body drop. First example I will consider. Next I will consider the second example. And next I will consider the third example. Okay. So now we have to see what happens in these three cases. So I have make a column here. So body which is dropped from height, first example. Under that I have to see all these three equation of motion, what it becomes. Here in place of A, you have to take it as, in place of A, you have to take it as G here. Okay. So now, what is this body which is dropped from certain height? That means an apple. For example, apple has been fell down from the tree. That means that apple won't have any initial velocity. That becomes, initial velocity will be 0. That means the body is in rest position and it fell down. Isn't it? That is a drop from the certain height means it fell down. And also, what happens to the first equation of motion? First equation of motion will become V is equals to, this is 0, I'll neglect it. A is nothing but it is G, acceleration due to gravity, G into T. Okay, this is the first equation of motion will become. Second thing, see here in place of S, distance, I'll consider it as height because the body is dropped from certain height. So in spite of S, I can consider as H. So here H is equals to UT, 0 into T is 0 itself, half A is GT square. So H is equal to half GT square will become. Similarly, let me consider this one. V square is equals to U square plus 2AS. V square is equals to, U value is constant. So that is 0, 0 plus. So I think this become 2GH. S is nothing but H. So this is for the first condition, a body which is dropped from certain height. Next condition what? The body which is dropped downwards. That means for example, you are standing at the 5th floor of a building, any building if you are considered, and you have thrown a stone or any object from that building, means that object will, initial velocity of that object won't be 0. It will be having some initial velocity for that object. And also here acceleration A is nothing but I'll consider as G, that is acceleration due to gravity. Now if I substitute that, V is equals to, U value will some be there, so that means it won't be 0, so that becomes U plus GT. Similarly, S means H is equals to UT plus half GT square. Similarly, V square is equals to U square plus 2GH. Okay, so this is about the condition of body which is dropped downward direction if you consider. Next, body which is thrown upward direction. So, how I can say this one means, the initial velocity will be some, it won't be zero. It will be some initial velocity will be there whenever you are throwing an object upward direction. And what happens to the acceleration? You know, whenever you are solving the problem, if the direction, if the body is thrown in vertically downward direction, means the acceleration, that is A value, will consider it as positive A value. Now, it is in this direction, in the opposite to the direction of gravitation. Gravitational force will be towards the downward direction. Am I correct? What is the gravitational force will be towards the downward direction. But here we are considering the body which is thrown upward direction. That means acceleration will become the negative value. That becomes A value. I'll consider it as minus G. Okay. So then what the value of V will become? V is equals to U minus GT. H is equals to UT minus half GT square. And V square is equals to U square minus 2GH. Okay. So these are the, by the three equation of motion, I can take the examples of these three objects. In all these three objects, the acceleration due to gravity, that is influence of gravitational force on an object, which remains constant in all these three cases. Okay. So this is about the equation of motion. Based on equation of motion, we are going to remain what are the things happening in the considering the three examples. Okay. So now, based on these concepts, I have given you the worksheet. So try to do it. If any doubts is there, we will discuss in an interaction section. Next, I am going to do under this chapter a very important thing, that is what is mass and what is weight. Because many confusions are there, whether you have to call it as a mass or whether you have to call it as a weight. So next class we will discuss about what is the difference between the mass as well as weight. Thank you, students.